Welcome to the Zero Pressure Podcast, a relaxed conversation with those on the cutting edge of science and technology, hosted by me, Helen Sharman, and presented by Imperial College London and Saab. I became the first British astronaut when I launched on a Soyuz spacecraft to the Mir space station in 1991. But before that, I worked in industry as a chemist, and more recently, I've managed research teams and operations and worked in universities. But I've always been passionate about science being more widely discussed. The Zero Pressure podcast series will be looking at how science and technology can contribute to solving complex, interrelated global challenges of today and tomorrow. We'll be looking at pioneering technologies and speaking to thinkers and doers at the leading edge. How can science and technology serve as enablers of the greater good, socially, environmentally, in terms of improving global resilience and for the long term as well? The podcast will have a special focus on security, be that protection for individuals, nations or the whole Earth, cyber or physical, from aerospace to deep ocean technology. If you'd like to ask me or our guests anything, please reach out to us on Twitter at Zero Pressure Pod, where we'll post answers. We may even feature your questions in the next episode. I look forward to hearing from you. Today we'll be talking about space in 2050. What developments are likely in the worlds of science and technology that will allow further space exploration, and how will that impact us on Earth? What about the increasing commercialisation of space? Should there be better regulation, and will space continue to become more accessible to more people, not just for human space travel, but for what we can make use of space? What about the impacts of our actions on space itself? Are there responsible space solutions? Christer Fuglesang knows just how personal a threat to safety in space can be. Christer is a particle physicist who became the first Swedish astronaut in 2006 when he flew as mission specialist on Space Shuttle Discovery to the International Space Station. Christer made a second shuttle flight to the ISS 3 years later when he helped to install upgrades to enable a larger crew then. Amongst his many and various current interests, he's now Professor at KTH Royal Institute of Technology in Stockholm. Welcome to Zero Pressure, Christer.
Well, thank you very much. Nice to meet you over the radio waves.
Tell me about your second mission in particular, because of course I've only ever trained for one. Did you approach your second mission in a different way to your first?
Well, yes. After one flight, you know what you can expect much more than for your first flight. So I could prepare better, I think. I could prepare my own things, which I wanted to do a little bit in my free time in another way. So it was a different flight, but just as fabulous. I mean, the first time is always first time, but because I could prepare and expect things in another way, the other one was just as good.
So what of your own things did you want to do? I mean, somebody once told me, make sure you look out of the window a lot because you'll regret it if you don't. I mean, what advice did you give yourself for the second time?
So I wanted to make some small videos, showing kids how water behaves in weightlessness, how you can play around with it. So I had some ideas and I managed to do that.
Super. It's fun, isn't it, with water being blobby?
Oh, yes.
Do you have a particular highlight from either of your missions?
Well, some of the real highlights was actually the spacewalks. I did 3 on my first flight and 2 on my second, or EVA as you call it in a more or less NASA lingo, extravehicular activity. And being outside is really special. And I do remember when I was on the very top of the space station, we were working on things. So I saw this fabulous construction under me. I mean, it's 100 meters wide. And then another 350 kilometers below was the Earth floating under me with spectacular views. And it was very powerful, the situation. Some things which really stood out, I saw auroras, how the huge green clouds or curtains almost moving. I was very fascinated by the nighttime. For me, it was like floating around a huge map, particularly when you were over areas where you were familiar with, like Europe. And the big lights from big cities, small lights, small cities, and they were often on the coast, so you had the coastlines lined out. Really, really spectacular. I mean, I don't know what you thought yourself. It was something which stood out, or
Yeah, well, I must say, the nighttime is, you're absolutely right. It's much easier to tell where cities are at night. So
yeah.
I guess for you, Sweden, absolutely, you've got the coastline there, particularly for Britain. We've got a lot more lights, I suppose, within the centre of the country. But I was amazed to see roads. I can see long straight roads. I could actually make out our major motorways running up and down and throughout the United Kingdom because of all the lights on the roads. Not the cars, of course, but the street lights. Just amazing things that we can see. Do you feel any more somehow isolated from Earth when you're outside the space station than when you're in?
Nah, a little bit maybe, yes, but you are very well connected by the radio waves all the time. So one side you are very kind of isolated. On the other side, I felt very well connected. We were solving a problem at one point with a solar array, which didn't want to kind of fold as it was planned. And we were two outside there, but we were working close to the people inside the shuttle space station and the mission control center in Houston, where there were probably 100 people following us. And felt very close to them, like, I had a tether to myself to the station, but I was almost tethered to the ground because we were working and solving the problem together, although we were on a very extreme place ourselves.
Now, having all of these wonderful connections makes me feel rather jealous, I suppose, because you would be aware that the Mir space station, which was a precursor, I suppose, in many respects to the International Space Station that you visited, but we didn't have such wonderful connections. Radio was fine, but only when we were directly over a line of sight of the Soviet Union, where they could relay these radios back to mission control. But you had... Would you say you had 24/7 communications if you needed it?
Not really, but close to. The gaps were never more than maybe 5 minutes or so. And not only that, it was even, and is even better now. My second flight was in 2009, but I could even call home, type in a telephone number on the computer, and signal went through the Mission Control Center in Houston and out on the international phone system. So I could call home, I could call friends in Sweden, which was quite surprised to get a phone call when they knew I was in space.
I can imagine the surprise. So what did you say? Hi, this is Christer. I'm calling you from space.
Kind of. Well, I just say it's Christer. No way, they say.
But of course, you got to ISS on shuttle, which is a totally different ride from Soyuz, isn't it?
Mm-hmm.
Now,
it is.
I suppose the thing I'm most jealous about on shuttle is that landing that you must have had. Tell us about the landing.
Oh, the landing with a shuttle, it was like an aircraft. A little bit rougher than a normal aircraft flight, but not worse than when you're in really bad turbulent air. And then, of course, you come from weightlessness. So you've been weightless my flights were around 2 weeks. So you feel very heavy when you land in your body, but nothing compared to the Soyuz.
It's a big bump. Yeah, Soyuz is. Some people say it's like a car crash, but it definitely. And you say you're comparing it to this feeling weightless, and then suddenly you've got all of this stuff coming down, and of course. You get that deceleration in the atmosphere before you land anyway. So you must have had that in shuttle beforehand. We had about sort of, I guess, 5G, just over 5G of deceleration. Do you get something similar?
No. Due to the wings of the shuttle, you can kind of fly the air much more. And we had a maximum of 1.6 G. And in our case, the maximum Gs was during the launch, where the shuttle it's only a two-stage rocket compared to Soyuz 3 stages. But it kind of grew up to 3G towards the end, and then it throttled down, and it kept 3G for about a minute at the end.
Did you have a window to see out of during the launch?
No, unfortunately not. I was sitting downstairs both my flights, so I never got the view during launch and landing.
So interesting to speak to Christer about his time in space and, of course, his spacewalks. Christer mentioned the landing in shuttle, how beautifully soft that was, and, of course, his launch getting up to the International Space Station. I remember my space flight as though it were yesterday. The build up to the launch in quarantine in Kazakhstan with my crew beforehand. We spent 2 weeks there. The launch itself, of course, the G-forces, the excitement, but, particularly, really, it's feeling weightless afterwards. That free, floating, relaxing feeling. Somersaulting my way through breakfast one day, I forgot what it's like to sit down, to sit anywhere, to stand up. I remember the smell of an experiment that I brought back in from space. I had to put that in an airlock and expose it to the space environment, and it comes back in with this very kind of metallic smell. I used to think that was just the bare metal that had somehow been made on the surface because the oxygen layer had been stripped away by space. But I now understand that's probably more likely to be something to do with some free radicals on the surface caused by radiation from space. And then, of course, there's that ride back to Earth, the deceleration of over 5G. It's physically harder than the launch. Seeing the plasma build up, this glowing ions on the outside of the spacecraft, the parachutes violently opening and then, of course, slamming into the Earth. We'd done all that, and I think 30 years ago I felt like we were pretty advanced compared to what poor old Yuri Gagarin must have been through 30 years before me. But of course now the International Space Station, and we're another 30 years on, we have come a long way in terms of comfort and what we can do in space. Shuttle was enormous, wasn't it, with that huge cargo bay. Do you think there's a need now for cargo and human launches together?
No, I think that was one of the big mistakes with the shuttle. The shuttle was really a fabulous vehicle. Launch as a rocket, fly as a satellite, and land as an aircraft. But it was ahead of its time. And then it was supposed to be cheap, but never became cheap, although it was reusable. It needed so much refurbishment between every flight, so it never became cheap. And it was not robust, as we know, with the two catastrophes on 135 launches. And one of the mistakes was to make one vehicle to fit all. That's a common mistake, right? So you want to be much more secure when you keep higher safety when you launch people than you need to be sending cargo to space. So it becomes a very expensive way to send cargo to space if you combine them.
Right, so you've got this triple compromise, really, rather than a triple advantage. But on the other hand, I just wonder, how far have we come? We've not really done anything else. We've not gone to Mars yet, have we? What is that imminent, do you think, now? It does feel like we're getting very excited about it.
It's not imminent. I remember the first time I got the question, when did we go to Mars? I think it was soon after I became an astronaut in 1992. And I said, 25 years. And then I've been given the same answer for a long time. But now I start to at least converge a bit. I think we will go to Mars in maybe 15 years. So it's not imminent. But it's in these times, because I would say it's in imminent returning to moon. I don't think we will be back on the moon 2024 as it was, or still officially is, the American kind of goal. But as they say, the first woman and the next man on the moon will probably be there in maybe 5 years' time. 5 to 6 years' time is my guess.
So that makes me, though, feel much more comfortable, because we're going to the moon in order to do something else, like go to Mars. So that makes it sound like it's much more sustainable, don't you think?
Absolutely. And it's not only the US this time, it's an international collaboration. Sure, it's led by the US, but it is an international collaboration. Maybe China will go there as well. I'm sure they will, but the time scale is not so clear. But China's very clear ambitions for space and even human space flight. Just the other day, they launched the first module to their own space station. And Russia, I'm sure, will be part of some of these programs. They don't have the resources to kind of go themselves. But now it's really to build up the infrastructure to stay on the moon and learn a lot of things that you need to know before we can go safely to Mars.
But do you think China and Russia are more likely to go off on their own, or perhaps as a bilateral agreement, separate from the rest of the world and with Artemis?
Yeah, now you say separate from the rest of the world. It's the US, Europe, and Canada, and Japan, and the rest of the world. I mean, maybe other people will join the Chinese, Russian, if China and Russia actually joins. I mean, they signed a memorandum of understanding to do some base on the moon, but I think it's good. I think it's good to have competition. So I would say it's better that there's two separate teams going to the moon than it would only be one.
Is that not going to cause some sort of? I'm just thinking about the Artemis Accords that NASA has published so relatively recently, wanting everybody to be transparent, and this is not really. Unfortunately, the way that we see sometimes with China and Russia, that they don't always tell us what they're doing until it's happened. Is there a way we can manage this so that everybody does benefit? Or do you think we just have to let individual nation states go off and do what they like?
On one side, we should try to set up rules that we all agree upon. But then when we have rules which we all can agree upon, then of course each partner or everyone is allowed to do what they want to do. It is like you have free trade and you have rules when you go to the Olympic Games to compete. I mean, we don't go to Olympic Games to kind of work together. It's a kind of competition, but it's under rules. So the ideal situation, I think, is we have agreed rules we all agreed upon, which are fair, and then there are several teams kind of trying to go as far as they can within these rules.
I just want to mention for listeners that you can submit your comments and questions via the podcast Twitter at Zero Pressure Pod, where we'll post answers. We may even feature your questions in the next episode. It'd be great to hear from you. In just a few decades, space has given us benefits that many of us already take for granted, like navigation and communications, weather forecasting, flood warnings, even letting farmers know when to harvest crops, and there's so much more. Since 1957, when we sent the first satellite into orbit, we've gradually added more and more, to the extent that now there are more dead satellites than active ones, and the number of planned satellites is rising exponentially. 143 have been sent into space on a single rocket. 143! There's a need for better space traffic management because of this, but the debris problem's not so much about satellites that are in use. It's about old, defunct satellites, parts of upper rocket stages, bits of metal and frozen fuel, particularly the remains of satellites that have crashed into each other. Now, there's an estimated 500,000 pieces big enough to be lethal, so even a small item like a fleck of paint can have enough energy to damage something like a space station window. My bedroom window on Mir was damaged like this just a couple of days before I arrived. It's quite possible that one more satellite breaking up in orbit would set into motion a cascade of collisions that could render a huge part of space around the Earth unusable. The International Space Station itself has made 28 collision avoidance manoeuvres since its first module was launched. And it only does this if tracking data shows another object looks like it's coming close by, and that's within about 25 kilometres of either side, front and back, and about half a kilometre above and below it. Affectionately, this shape around the ISS is called a pizza box. So, Christer, did you see any evidence of damage on the outside of the space station when you were doing your spacewalks?
Well, there's certainly damages there, and it's actually has become a little bit of a concern that on handrails, for example, which you grab onto when you move around in spacewalking, the space debris or perhaps micrometeoroids, they make small craters in there, very sharp. And at some point, when someone noticed when he or she came back that there was damage on the glove, so people got concerned that that can create a leak in your gloves. So that's another thing, and people have to check their gloves now and then due to small kind of craters on handrails. And
wow, so this isn't the glove being impacted directly by a micrometeoroid, but being damaged by the rail.
Yeah, so
Wow.
no, so far no one has been hit by a big enough thing to really make a dent or hole in the spacesuit. But no, it is a concern. It is a problem. From 1 centimeters and upwards, it's still very dangerous because they travel with speeds of order 10 kilometers per second. The relative speed between a space debris and a satellite, it could be order of 10 kilometers per second. Huge kind of energy. So they are very bad, and you can't see them when they're more smaller than about 10 centimeters, and there's an order of 1 million of them in low Earth orbit.
Yeah, it's a lot, isn't it? And I suppose the argument is, well, there's a lot of space out there for them to space themselves out in. So we don't kind of notice them flying past the window, do we, when we look out of the window, or presumably when you look out through your helmet?
And if they're big enough, and I say big enough, it is about the size of a fist or bigger, then you can track it from ground with radars. And that is done continuously. And if any of these pieces threatens to come close to the space station, and close here is 1 kilometer, then one makes a maneuver of the space station. Actually, you move the space station a bit so you kind of get out of the way for the space debris. Of course, over time, there's a risk that some satellites will get damaged, and there are indications that some has been damaged, even the kind of then stopped working. So we need to take care of this, needs to be planning, and first of all, we need to put into more regulations. All spacefaring nations and entities needs to kind of agree upon rules that we don't make more of these space debris. Very hard to get rid of them once they're there.
What happens if there's a rogue nation that decides just to go ahead anyway and not abide by any of the rules?
Well, like China did in 2007, they shut down one of their, or not shut down, they kind of They shot and destroyed one of their own satellites on the altitude of 800 kilometers, and the amount of space debris not really doubled, but it became much more. That's bad. I mean, what can we do? Well, we need to have rules that everyone kind of abides to.
Yes, so this was, of course, the Chinese anti-satellite sort of test, wasn't it? And because there's been crashes as well, a couple of satellites crashed that created a huge amount of debris. But the other side of things as well is what happens if it doesn't have to be, I suppose, anymore a nation, a state, an agency. It could be an individual who somehow manages to hack into a satellite at some point. Do you think that's likely to happen?
That has happened already. So, but in that case, you can maybe get to control that satellite, but that from there to create a lot of debris is very difficult. I mean, you can't really get that satellite to collide into another satellite, at least almost impossible, I would say. So the hacking problem is certainly also a problem, but it's not as problematic as when you destroy a satellite with a kinetic hit.
Yeah, sure. One thing's but much more sort of you're just looking at a particular satellite with intent in that specific way. But I'm just thinking sort of if somebody got into the navigation systems of a satellite, instead of allowing it to maneuver around another satellite in some sort of space traffic management way, they might deactivate that space traffic management, and then you're more likely to get two colliding, aren't you?
First of all, very few satellites have a lot of propellants, such that even if you hack into it, you cannot make it to go into another orbit, which you would need to maybe then hit some other satellite. Now, if that would happen, then you would still be able to maneuver the other satellites, probably. Not the very smallest one, because they don't have propellants or maneuverability, but some bigger one.
Okay, I like your optimism that's less
well, I
likely
mean, the space debris is a real concern, and that you can satellites can be hacked into and taken over. Yes, that's also a concern. But that you hack into it, take over a satellite, and then manage to get that to collide to another satellite, that is to me not very likely.
Is there some other mitigations we can make about the space debris?
Well, the first is to have regulations. Absolutely, and today, if you send something up, it must come down within 25 years after it stops kind of operation. But that's a very lax rule, and many small satellites they don't have a propulsion system themselves. So maybe it should be a rule in the future that every satellite has propulsion systems that you can bring it down once it's stopped working. And there should also be some kind of fail-safe system that you can get down. They should all have a transponder. So you don't need to have a passive, an active radar to kind of bounce off signals to see where it is. But if every satellite actually has a transponder like aircrafts have, then we can much easier track them.
Of course, that would make it more expensive, though, wouldn't it, having these extra systems on some of the cheaper little satellites?
It will make it more expensive, yes, but it might be necessary. Safety and security always comes to a price.
Yeah, sure. So how can we clean up debris? What do you think? Can we actually clear up what we've got up there? And should that be regulated?
What we can do today, technologically, I would say, is to go up there and get down one or two old satellites. They are big enough so you can see them, you know where they are, you can maneuver yourself to them. But it's almost like a one-to-one. You send up one satellite that can bring down one. Or you send up a very big one and it can maybe bring down a few. I actually had, together with two students, an idea. We looked at electrical propulsion is the most efficient way if you're not in a hurry. It's the most efficient way to use propellant in space. And that is throwing out, ions, typically very high speed. Well, if you go up in space and you put yourself very close in front of a dead satellite you want to get down, and then you run your ion electrical propulsion engine and you kind of shoot your exhaust against the other satellite, that will then get the kind of slight force breaking its speed. And then it would kind of eventually then break speed and come down. But it costs a lot of fuel to move between orbits. Another method which I've been discussing in an experiment is that you actually shoot a laser on it. That would work for small pieces. So you put a laser on it, and through ablation you would actually get a little then counter force if you shoot in the right direction, which would break the speed and come down. And that could work for the smaller pieces. But again, you would need to put hundreds of these lasers for a long time, and then kind of you just watch and you see a little piece now and then, and you shoot at it and get rid of it. It's not very efficient for sure.
No, but it is a gamer's dream, isn't it? So if you're into gaming, maybe there's a future for you out there in laser shooting bits of space debris. But what other threats from space concern you?
There are, you have to protect the Earth from threats from space. And one is that are asteroids who could potentially be a fairly big one who can hit the Earth and create a catastrophe like when the dinosaurs were more or less extinct. So we need to keep an eye on that, and the way to protect it, if some asteroid is threatening us, is to kind of send something to the asteroid and deflect it somehow. Another thing, due to the greenhouse gases, that we're increasing the global temperature. If that goes too fast, it's a big problem for civilization. And if we cannot control that by decreasing quite drastically now the emission amount of carbon dioxide primarily, then a possible backup solution could actually be to put sunshades in space between the Earth and the Sun. In absolute terms, you need something pretty big, 5-10 times the area of Sweden. But in kind of the more, let's call it planetary terms, so it's not impossible at all. And I think it might be actually a cheaper way to maybe prevent us from going the temperature too high and take the cost that would be.
So you're talking about some sort of deflection system, so possibly like a mirror, something like that, are you? Or something that would just absorb the solar energy and stop it reaching the Earth?
Yeah, just like sunshades which you have when you're outside the sunny day and you go for a cup of coffee under a cafeteria and it's 30 degrees centigrade and the sun, you just sit under a sunshade. So something like that, but a little bit more fancy. And you can actually combine it with something very interesting technology, which is called solar sailing, which is that you use the light from the sun to kind of propel yourself in space. And it sounds counterintuitive that you can actually go towards the sun, that's from where the sunlight comes. But it has to do that The reason if you send a satellite into space and let it kind of leave the Earth's gravitational field, it's that it has such a high speed around the sun, like the Earth has. The reason the Earth doesn't get pulled to the sun is that it has very high speed, exactly like satellites going around the Earth. It have high speed. But if you decrease that speed, then you will start to fall towards the sun, and you can do that by kind of having sunlight on a solar sail, and then you decrease the speed of the what I call sailcraft, and then it kind of starts to move towards the sun.
Sounds all very Star Wars, doesn't it? But if you reckon it's...
No.
I'd love to see that as using that energy. I mean, we're desperate for energy on Earth. Like you say, we don't want to burn our fossil fuels anymore. We don't need the global warming. But can we not use that energy from the sun and somehow direct it back to Earth in a targeted way that we could use? I don't know, maybe by a microwave or something, rather than just somehow deflect it, absorb it, waste it almost.
No, I don't think that's efficient. If microwave, transforming solar light, optical light to microwaves and beam it to the Earth, then I actually think it's better to have such absorbers or transformers, whatever, close to Earth in orbit. But technology with better and cheaper solar arrays on Earth, they're getting so much cheaper every year. So I think soon, probably more efficient to put fairly big arrays in desert or something like that.
Yeah, I would like to stay on this positive note, but there's something that I feel we haven't quite investigated yet, which is the proposed militarization of space, and perhaps how that might impact on security on Earth. Is it something that we should be concerned about, or do we think that because humanity's shown how good we can be, we can continue to be cooperative?
Yeah, it is unfortunately happening, and after the big arms race with all the nuclear weapons, at least kind of got some agreement how to control it, and there are agreements against chemical weapons and biological weapons. I hope we can get some regulation, but completely move away from militarization, if you want to call it that, in space, I don't think that's realistic. And some of it is actually, I think, stabilizing the Earth. I mean, the surveillance, Earth's observation by satellites over space, which may be one of the very first utilizations of space, actually. You see what other guy is doing, and then you don't have to suspect and kind of maybe make a first strike before the other guy do something bad, because you can see what he's doing. So I think that's also had to be recognized has been a stabilizing, peacekeeping effect.
By the time we reach 2050, I hope we'll have a global strategy for our use of space, what we want to achieve with it and how to ensure, I suppose, we all play nicely together. I'd like us to be collecting energy to beam back to Earth, which could allow us to use energy without affecting the climate. And I'd really like us to use space for orbiting factories. And I'd love us to be able to produce new materials to either use in space or even possibly bring back to Earth. This will be a great time to bring back Christer. Tell us a bit more about what you think let's say 2050. So you said Mars perhaps in 15 years, but in 2050 we might be even a bit past that. How do you think we're going to be looking in 2050 in terms of space exploration?
Well, I think there will be a established research base for sure, with permanent people on the moon since a long time. Maybe even possible to get some resources out. I certainly will be able to find resources on the moon which can help people staying there. There's water in the regolith, the sand there. There will be people living on Mars, maybe some kind of kernel to start some colonies. I think there will be also mining on asteroids. If there probably mainly be robotics, but I think humans will be traveling at least between Moon, Mars, and Earth in a regular way.
So, do you think, going back to ownership of space in a way, if somebody lands on an asteroid and mines it, say some company or some country, should they be able to own commercially the stuff that they mine, they bring back to Earth possibly?
Absolutely. I mean, otherwise we'll never have any use of it. I mean, no one will go there to just get it and then give it to people on Earth and say, hey, I brought this for you to use. Now, there should probably be some kind of, it's called taxes on it. But it's like all kind of business we're doing. People are allowed to produce things and then they can sell it and make money, but then they pay taxes for it. We have to have that right, that if you go there and you mine it, you have to get the profit out of it.
Forgive me, I'm going to say something rather political. I'll say spoken like a true Swede talking about taxes.
Yeah, taxes maybe not the right word, but it's also fair that, I mean, it doesn't even have to be taxes because they do it on asteroids. I mean, if they make profits on Earth, then every country has taxes on the companies, so hopefully we should have some kind of fair tax level for the same all over the world.
Is this something that that we need to do globally, or are you quite happy that that we just go off and let individual organisations do what they like?
Well, it's like all human activities. It has to be done within regulations, which we should hopefully as many as possible agree upon, which are the good laws or regulation. But if you say, well, we're going to do this globally together, it goes too slowly, and it has to be paid by tax money, and tax money are never enough. To be able to let's say, if you want to explore Mars as much as possible, you don't get much research money on Earth to go to Mars and do a lot of exploration just for do that. But if you also have a way that there's an economic interest to go to Mars, then you get a lot of free ride, and then you bring with you scientists and they go out and they look at it. I mean, so it's a combined thing.
What are some of the biggest challenges living on Mars? We know about, of course, getting oxygen. What else?
Getting oxygen, you have to start to live in some kind of cupola or underground or something, and maybe underground, because another challenge is the radiation. There's a lot of particles out there in space, and they can cause bad things to our bodies. Radiation, you can get cancer, and we don't really know how dangerous it is, but it might be such that we need to protect ourselves quite well and live underground or build some really thick walls around in the houses. It's cold, very cold, and then we know there's water there, that's for sure, but we need to find the best way to get that water to where we're living, and then use that water to create oxygen, and also to create rocket propellant. Maybe not only from water, but also from the methane which is in the air.
You see, as a chemist, I would say this is wonderful. We're using chemistry in order to live elsewhere at some point, which will be very interesting to see how we can drive the chemistry in the direction that we need it to work for us. But what about for us personally? As I'm not sure whether you or I will ever go to Mars. We might be a bit old for that. But for people on Mars, I mean, is it not the communications that's going to be the really big thing? You know, how long it takes to talk to the ground, to the Earth ground, of course.
Well, I think we're talking two different times here. In the very beginning, there will be just an expedition there, and they will be quite depending on getting help, also, I mean, advice and what to do, etc., with the Earth. So they need to communicate a lot for their survival, basically. But in a little bit longer term, you have a kind of colony there, and people talk to each other, and they won't have that same need to talk to us. But in the beginning, one of the big challenges going to Mars will definitely be the communication. That they need fast answers for survival and things like that. Very big difference compared to being on ISS and the space station or Mir before. You can always get home within a day from space station, from Mars. If the current technology, if you start your trip to Mars, the minimum will take 1.5 years before you can get back with current technology. But I think in the future we will have better rocket engines in space. So we'll go faster, and we might even have a chance to what we call abort the mission and come back maybe within months instead of a year and a half.
Yeah, for sure. So we're talking chemical propulsion to get off the surface of the Earth, and then possibly electrical propulsion ion propulsion to keep going faster and faster to accelerate in space?
Yes. So if you don't need to have very short, very forceful acceleration as you need to get out off the ground, then you can use electric propulsion or plasma propulsion, and that's not very high force, but you use it for a long time. It's more efficient if you just have a very small acceleration, but if you use it for many days or even weeks, you get very high speed.
Yeah, sure. And would you do it for yourself? Would you go to Mars?
I'd love to go to Mars, but I will not go for a one-way ticket. I like to come back also. For absolute most people, it will be much more nicer to live on Earth than on Mars, but there will always be many people who just love the idea to kind of be the first to move to another planet, to kind of establish a new place for humanity and all that. So it will never be a problem to find people who want to go there.
What one issue is the thing that you think we need to have solved by 2050?
Oh, and it should be space related?
Yes, but by 2050, in terms of space, what do you think we need to solve? It doesn't have to be in space, but what could we be using space for? Maybe it's a positive. What do you think we can actually use space for to protect us on Earth, or what do we need to solve for the future?
To learn how to live in outside the Earth. How to live on Mars. I definitely don't think we will lose the possibility to live on Earth, but it's always good to, in a long-time future, have a planet B to live on. If that huge comet would hit us and we don't have a time to deflect it.
Christer, thank you very much. Just fascinating thinking about, of course, it's that joy of exploration that you still have, that enthusiasm, but all of those extra thoughts about what we're going to need to do internationally, and your sunshades idea. So this is so lots of new technology to get excited about for the future. Thank you.
Thank you for having me, Helen.
And thank you for joining us on this podcast journey. It's great to have you on board. Wow, what a discussion to think about now. Regulations on space and future technology to consider. If this conversation sparked any burning questions, or if you'd like to ask me or our guests anything, please reach out to us on Twitter at ZeroPressurePod, where we'll post answers. We may even feature your questions in the next episode. I look forward to hearing from you. If you've enjoyed this episode, please leave us a positive review wherever you're listening to your podcast, and don't forget to subscribe. In our next episode, we'll be exploring autonomous systems. What sort of decisions will artificial intelligence allow? And on what bases will they make that choice? Could be a self-driving car faced with hitting a pedestrian or colliding with a wall, or another vehicle even. Or a military drone deciding which targets to destroy. How much autonomy should systems have? I'll be talking with two world-leading researchers in artificial intelligence ethics, so do join us for that zero-pressure conversation. If there's a particular topic you would like us to explore, it'd be great to hear from you, so please just visit us at ZeroPressurePod on Twitter. Until we meet again, here's a few words from Stephen Hawking. Look up at the stars and not down at your feet. Try to make sense of what you see and wonder about what makes the universe exist. Be curious.